Hello students, once again welcome you to GK's maths classes. Today in continuation of this chapter continuity and differentiability, we are going to solve more problems. Today in fact we are going to focus on differentiability of a function. Okay, so those are the things we are going to do. So straight away let's get inside the video. Now first is some introduction I'll give you. What we have already done in part 1 of our continuity. I will put it as a description. I put the link in the description box for your reference. I will just give you a rough idea of what continuity is once again as a routine. Okay, so when you say a function is continuous at x is equal to a, you say the function is continuous at x is equal to a if it satisfies three conditions. What are they? The first one is the limit should exist. The limit f of x is exist. And what's the second condition? F of a must exist. And the third condition is the limit and f of x must be same. They must be one and the same. Limit should be equal to f of a. So if these three conditions are satisfied, you can say the function is continuous. And you know the limit exists when LHL is equal to RHL. This is what we have been doing for the past 3 classes. Okay, so I think this is clear to you. Now what is differentiability? Okay. Differentiability is whether it's possible for me to differentiate a function. Okay. Now what do you mean by differentiation? You know, when I have a function y equal to f of x, it will always represent a graph, right? It will always represent a curve. Okay. Now there are infinite points on the curve where I can draw a tangent. I just draw a tangent. Yes, I'm able to draw the tangent. If I'm able to draw a tangent is a line that touches the graph exactly at one point. If I'm able to draw a tangent, that means it is possible for me to differentiate, because the geometric meaning of dy by dx is slope of the tangent to the curve at each and every point on the curve. This is all you have studied in 11th standards. So we'll do that a little later when we do differentiation. But differentiation means when I say a function is differentiable, that means I'm telling that it is possible for me to draw a tangent. Okay. When can I draw a tangent? If the curve is smooth like this. If I have a sharp edge, like this, for example, like this, wherever there's a sharp edge, it is not possible for me to draw a tangent. So at this point, the function is not differentiable. Okay, that means, what do you mean by not differentiable? It means you cannot draw a tangent there. Or if you draw a line, that is not a tangent. You understand? So differentiability means it is possible to differentiate. It is possible to differentiate means it is possible to draw a tangent. So when can you draw a tangent? You can draw a tangent to a curve only when the curve is a smooth curve. That is why differentiable functions are also called smooth functions. Okay, that's a different aspect. When the curve is not smooth, if it is having a sharp edge, at the sharp edge you cannot draw tangent. So at that point the function is not differentiable. So that is what it meant by a function is differentiable, function is not differentiable. Okay. So whether it's possible for me to draw a tangent or it's not possible to draw a tangent. Okay. Now last year you studied first principle differentiation. So I'm going to use the same idea here. So for me, this is the formula. Whether it's possible to differentiate. This is called left hand derivative of f of x. Left hand derivative of f of x. The formula is, I will use this formula. This is easy for me. X approaches to a minus f of x minus f of a divided by x minus a. This is actually left hand derivative of the function at x is equal to a. Now what is right hand derivative? My right hand derivative is right hand derivative of f dash of x, where at x is equal to a is limit x approaches to a plus f of x minus f of a divided by x minus a. Okay, you can see this is nothing but slope of the secant. So when limit x approaches to a, secant becomes a tangent. That's what we have done in class 11th. So if you go back and check class 11th first principle, you will understand all these things. So when I say f dash of x exists, when I say it exists where? At x is equal to a, that means my left hand derivative must exist, right hand derivative must exist, and both should be equal. If my left hand derivative and right hand derivative exist, and if both are equal, then you say the function is differentiable. Now just to give you a quick idea of that graph, see this, you have the function, one second, this you have the function y equal to f of x. Okay, so if I take this as x comma y, this will be say a comma f of a. Okay, so if I draw a secant, what is the slope of the secant? It is y2 minus y1. This is y2 minus y1 by x2 minus x1. So remember, this means slope of the secant. So when I say limit x approaches to a, that means slowly this value, this p, this point p approaches to q. P is approaching to q. When p approaches to q, this secant will slowly become a tangent. You see, it will slowly become a tangent. So when it becomes a tangent, it becomes f dash of x. So that's the idea. We have this is done in detail in class 11th. Okay, so I will not go into that now because otherwise time will be wasted. So differentiable means left hand derivative should exist, right hand derivative should exist, and both should be equal. And I hope you also understood the meaning of f of x minus f of a by x minus a, which is slope of the secant, which becomes the slope of the tangent when x approaches to a. I have shown you this. Okay, let's go to the problem. Now show that the function y equal to modulus of x minus 3 is continuous but not differentiable at x is equal to 3. Very famous and very important type of question. Okay, so first of all, let's talk about definition of modulus of x minus 3. What is definition of modulus x minus 3? It is x minus 3, x is greater than or equal to 3, minus of x minus 3 when x is less than 3. You know the definition. Okay. Now, first left hand limit. So what is left hand limit? Limit x approaches to 3 minus f of x. 3 minus means what? X is less than 3. If it is less than 3, what is my function? X approaches to 3 minus, it is minus of x minus 3. So when you apply the limit, you get 0. So my left hand limit is 0. So what is my right hand limit? My right hand limit is limit x approaches to 3 plus f of x, which is limit x approaches to 3 plus means x is definitely greater than 3. Greater than 3 means what is the function? It is x minus 3. So right hand limit is also 0. So clearly LHL is equal to RHL. So what do you know when LHL is equal to RHL? It means only that limit exists. It does not mean the function is continuous. It means only limit exists. And what is that? It is 0. So first condition is satisfied. What is the second condition? I have to find f of 3. Substitute. When I put x is 3, you get 0. So second condition also satisfied. Third one is what? Clearly both are equal, right? So limit x approaches to 3, f of x equal to f of 3. This implies the function is continuous at x is equal to 3. This shows the function is continuous at x is equal to 3. There is no confusion at all. Okay. Now I have to talk about differentiable. How do I do differentiable? So let's go to left hand derivative. I want to find left hand derivative of the function at 3. So what is that? Limit x approaches to 3 minus f of x minus f of a by, here it is f of 3 by x minus 3. Correct? Now, since 3 minus x is less than 3, what is my function? My function will be minus of x minus 3. My f of x will be minus of x minus 3. But f of 3 is 0 divided by x minus 3. So they get cancelled. So my left hand derivative is minus 1. My left hand derivative is minus 1. Now what is my right hand derivative? Right hand derivative of 3 is limit x approaches to 3 plus f of x minus f of 3 by x minus 3. Since this is greater than 3, what is my modulus? What is my f of x? My f of x will be x minus 3, and you know f of 3 is 0, so I don't have to write that. So you get 1. So clearly LHD is not equal to RHD. If LHD is not equal to RHD, you can say the function is not differentiable at x is equal to 3. What do you mean by not differentiable? Not differentiable means it is not possible for me to draw a tangent. Why it is not possible for me to draw a tangent? We'll find out why. Because it must be having a sharp edge. Okay. Let us see what is the graph is. Let's go into the graph a bit. Okay. Now let's see the graph of modulus. A, B, S of x minus 3. X minus 3. Look at this graph. Look at the graph. Is it continuous? It's perfectly continuous. There is no break at all in the graph. Okay, you can just move it around. It's perfectly continuous. But is it differentiable at 3? No. Why? Because there is a sharp edge. I told you, right? When there is a sharp edge, you cannot draw a tangent. You cannot draw a tangent means you cannot differentiate. That is why we got the function is not differentiable. Where it is not differentiable? At 3. Let's go back to our regular work. Now, very, very, very important question. Slightly complicated also. Y equal to modulus of x plus 2 minus modulus of x minus 1. And before I go to this, I want to make one statement. Very, very important statement. I'll put it here. Now, what is the statement? The statement is every differentiable function will be continuous. But all continuous functions need not be differentiable. So what does it mean? Continuity do not imply differentiability, but differentiability implies continuity. If I say a function is differentiable, it has to be continuous. If a function is continuous, it's not necessary that it has to be differentiable. It is not necessary. Okay? So keep this in mind. It will help us. Now, let's go to this wonderful problem. Y equal to modulus of x plus 2 minus modulus of x minus 1. Before I do it, I want to write the definition of modulus. y equal to modulus of x plus 2, I'm sorry, not y, modulus of x plus 2. What is the definition of modulus x plus 2? It is nothing but x plus 2, x is greater than or equal to minus 2, minus of x plus 2, x is less than minus 2. So first, the basic definition. Now what is definition of modulus x minus 1? Modulus of x minus 1 is x minus 1, x is greater than or equal to 1, minus of x minus 1, x is less than 1. Okay. So what I have done, I have not done anything, just rewritten the definition of modulus x plus 2 and modulus x minus 1. Okay. Now where does this function have problem? If at all it has discontinuity or non-differentiability, it has to be only at minus 2 and 1, because that is where you are having two different functions. To the left of minus 2 it is minus of x plus 2, to the right of minus 2 it is plus x plus 2. So there are two different functions. So the problem, if it exists, it has to be at minus 2 and 1. Okay. So what I do, I take the number line and just keep it here. This is for my reference. This is my, I'm just sorry, this is my number line. Now, okay, now let me mark the point minus 2. Let me mark the point 1. So this is split into 3 intervals. So I'm going to redefine that function. See how I do it. I write f of x equal to, there are going to be 3 functions. One will be minus infinity less than x less than minus 2. That is this region. Minus infinity less than x less than minus 2. The second region is minus 2 less than x less than 1. That is this region. And then 1 less than x less than infinity is the third region. So I am breaking this 3 into 3 equal parts. Minus infinity to minus 2, minus 2 to 1, 1 to infinity. Okay. So I have done that. Now what I do, I take the function. Now here, if you look at this region, definitely x is less than minus 2, correct? Not only that, x is also less than 1, correct? From minus infinity to minus 2, my values are less than minus 2 as well as less than 1. So if it is less than minus 2, what is the definition of modulus? It will be minus of x plus 2, minus of x plus 2, because it is less than minus 2. This minus sign is already there, so put that minus sign. Now x is less than 1. What is the definition of modulus? It's again minus of x minus 1. Do you get that? Less than minus 2, so it's minus of x minus 2. This minus sign I'm writing as it is. Modulus of x minus 1 is less than 1. So since it is less than 1, I write minus of x minus 1. If you simplify this, what do you get? Minus x minus 2 plus x minus 1, which is nothing but minus 3. So I just have to write minus 3 here. Understood or no? Is it clear? Now let's come back to this. In this region, x will be definitely greater than minus 2, right? It's greater than minus 2, but it is still less than 1. It is still less than 1. So what is definition of modulus x plus 2? It will be x plus 2. It will be x plus 2 because it is greater than minus 2. But since this is less than 1, first you put this minus sign. And what is the definition of modulus x minus 1? Minus of x minus 1. Why it is minus of x minus 1? It is less than 1. If it is less than 1, it is minus of x minus 1. Now open the bracket. X plus 2 plus x minus 1, which is 2x plus 1. Just write 2x plus 1. Okay. Now here if you see, it's greater than minus 2 this region, and it is greater than 1. So the modulus will be x plus 2. This minus sign is from the question, and modulus of x minus 1 is again positive, so it is x minus 1. Now open the bracket, what do you get? So you get 3. So I have redefined my function. My function y equal to modulus of x plus 2 minus modulus of x minus 1 is redefined like this. I hope there is no confusion. This is the first step. Okay. Now I am going to do the first subdivision. I want to find point of discontinuity. So point of discontinuity means it can be discontinuous at 2, minus 2, or it can be discontinuous at 1. So let's talk about 2. Talk about minus 2. Left hand limit. So what is left hand limit? Limit x approaches to minus 2 minus. When I say minus 2 minus, it's less than minus 2, right? So if it is less than minus 2, what happens? And here there's another problem. I have not done it correctly. I have to make some correction. See, equal to is missing. So you can put wherever you want. I put equal to here. If you put it here, don't put there. Okay. So limit x approaches to minus 2. It's less than minus 2 means the function is minus 3. So my left hand limit is minus 3. Can you see that? Left hand limit is minus 3. Now let's go to right hand limit. What is my right hand limit? RHL. Limit x approaches to minus 2 plus. Minus 2 plus means it's greater than minus 2. If it's greater than minus 2, it has to be 2x plus 1, correct? If it is 2x plus 1, what do you get? Minus 4 plus 1, therefore it's minus 3. So what do you say about LHL and RHL? They are equal. So LHL equal to RHL. If LHL is equal to RHL, what do you know? Limit x approaches to minus 2, f of x equal to minus 3. Limit exists. If limit exists, can I say the function is continuous? Definitely no. What I have to verify? I have to verify f of minus 2. Where will I put? This is where you have equal to sign, so put it here. So you get 2 into minus 2 plus 1, which happens to be minus 3. Wow. Therefore, limit x approaches to minus 2 f of x equal to f of minus 2. So I had my doubt at minus 2. My doubt is cleared. Clearly, the function is continuous where at x is equal to minus 2. The function is continuous at x is equal to minus 2. So one doubt is cleared. Okay. Now my second doubt. I'll take this function. I need it. My second doubt is let me have it here. Okay. Now my second doubt is about x is equal to 1, whether it's continuous or not. So take x is equal to 1. So what is my left hand limit? My left hand limit is limit x approaches to 1 minus. 1 minus means definitely less than 1. Less than 1 means it is 2x plus 1, which happens to be 3. Correct? And you put x is 1. Now what is your right hand limit? My right hand limit is limit x approaches to 1 plus. 1 plus means definitely greater than 1. If it is greater than 1, the function is 3 itself, independent of x, so the limit is 3. So clearly, LHL is equal to RHL. This implies, can I say function is continuous? Definitely no. I can say the limit exists. What is my limit? Limit is 3. Now what is my f of 1? Equal to is here. F of 1 will be 2 into 1 plus 1, which is 3. So you can see clearly, limit x approaches to 1, f of x equal to f of 1. So what do you say? The second doubt is also clear. The function is continuous at x is equal to 1. Now if you see this problem, point of discontinuity, if any. I have the doubt at -2 and 1. Nowhere else it can have problem because all these are polynomials. All polynomials are continuous. But since they are all different polynomials, I want to know whether there is a link involved. And there is a link. Okay. So clearly you can see the function is continuous at -2 and the function is continuous at 1. Otherwise, everywhere else it is already continuous. Therefore, you can say the function has no point of discontinuity. It has no point of discontinuity. This is my first part of the question. This is my A. Now, what is my B? My B part of the question is, I want to know whether the function is differentiable or not. So again, my doubt is only at -2 and 2. So let me check. Okay, at -2 and 1. So let's talk about differentiability. Differentiability. Just a second. Okay, what do I do? At x is equal to 1. Left hand derivative of 1. Now, what is left hand derivative of 1? Limit. I will start with -2. So that's the first number, no? So -2. So left hand derivative of -2. What is that? Limit x approaches to -2 minus f of x minus f of -2 divided by x minus of -2. Here my A is -2. Therefore, this will be limit x approaches to -2 minus -2 minus means less than -2. Less than -2 means my function is -3 and my f of -2 will be -3 divided by x plus 2. Obviously, my left hand derivative is 0. You can even verify. So what is differentiation of -3? It is 0. So I got the same answer. If it is a 1 mark question, you don't have to do all this. You can just do directly. Now, what is right hand derivative? Right hand derivative of -2. Now, let us estimate the answer. Right hand derivative will be differentiation of 2x plus 1. So, differentiation of 2x plus 1 is 2. So, the answer should be 2. We'll find out. So, this is limit x approaches to -2 plus f of x minus f of -2 divided by x minus of -2. So, this is limit x approaches to -2 plus f of x is what? -2 plus means greater than. So, it is 2x plus 1 minus, what is f of -2? f of -2 is -3 divided by x plus 2. So, this is limit x approaches to -2 plus, if you simplify this, you get 2 common, you get x plus 2, because this will be x plus 4, this will be 2x plus 4 by x plus 2, they get cancelled. And what is the right hand derivative? It's 2. So clearly LHD is not equal to RHD. This implies the function is not differentiable where at x is equal to -2. It was continuous, but it is not differentiable. Now let's go to the next part. What is that? At x is equal to 1. Let's look at x is equal to 1. At x is equal to 1, what is my left hand derivative? Let's go slowly. Limit x approaches to 1 minus. 1 minus means less than 1. Less than 1 means what is the function? Okay, I'll just write the function first. F of x minus f of 1 by x minus 1, which is limit x approaches to 1 minus. So this is 2x plus 1 minus, what is f of 1? F of 1 will be 3 by x minus 1. So this is limit x approaches to 1 minus, you can see clearly 2 is common, you get x minus 1 divided by x minus 1, they get cancelled. My left hand derivative is 2, because obviously 2x plus 1 differentiation is 2. Now for the right hand derivative should become 0, because differentiation of 3 is 0. Let's see that. So right hand derivative of f dash of 1 will be limit x approaches to 1 plus f of x minus f of 1 by x minus 1, which is nothing but limit x approaches to 1, 1 plus means greater than 1, so it has to be 3, and f of 1 is also 3, so that's great. So answer is 0. So clearly left hand derivative is not equal to right hand derivative. This implies function is not differentiable where at x is equal to 1. So the point where the functions are not differentiable is minus 2 and 1, even though the functions are continuous at minus 2 and 1. This confirms that continuity need not imply differentiability. Okay, so that finishes the second part of the question. The third part, sometimes I'll ask, sketch the graph of this function. So let's see that part. Okay, now how do I sketch the graph? I think I need some space, so let's go to this. I need the graph. I want to draw the graph of this function. Now how do I draw the graph? First let's take x-axis. Let's take x-axis, and I want the y-axis, x-axis and y-axis. That's perfect, well done. X-axis and y-axis. Now let's mark the point minus 2. So where is minus 2? This is where I have minus 2. Let's mark the point 1. So this is where I have the point 1. Okay. Now there are two parts to it. Okay. Now what is the first part? X less than minus 2. The function is y equal to minus 3. What do you mean by y equal to minus 3? Y equal to minus 3 is a straight line parallel to y-axis at minus 3 comma 0. So this is where I have 0 comma minus 3. Okay. So now this is the line. Let me give it a red color. So this is the line. Okay. It goes on, correct? But it cannot be here because it's very clear that x is less than minus 2. So what do you do? Just bring it to here. So it's less than minus 2. And put a small ring here. Why? Because it's given less than, right? So that minus 2 is not included. So this is y equal to minus 3. Clear? Now, from minus 2 to 1, the line is y equal to 2x plus 1. 2x plus 1 means slope is 2 and my y-intercept is 1, because this is of the form y equal to mx plus c, correct? Now y-intercept is 1 means where this is 0 comma, this is 0 comma 1, 0 comma 1, and this is 0 comma 3. I need that also. This is 0 comma 3, and this is the line. Let me just draw this line. So it goes from here. Okay, it goes up to this point. Okay, what is this equation? It's not exactly that. Okay, somewhere. Can't be accurate because I'm not using a scale. So this is actually y equal to 2x plus 1. Now finally, for greater than 1, it's y equal to 3. So y equal to 3 is a straight line parallel to y-axis 0 comma 3. So let's take that green line. So this is the line. I'm sorry. So it goes on. It can't be here because, because it is only from greater than 1. So this is how the graph of, this is how you draw the graph of, this is y equal to 3. This is how you draw the graph of y equal to modulus of x plus 1, x plus 2 minus modulus of x minus 1. and you can see there are sharp edges at minus 2 and 1. That is why the function was not differentiable, whereas you see it's perfectly continuous. Okay, I'll just show it on GeoGebra also so that you can experience that. Let's come back to this. It's plus 2 and minus absolute x minus 1. It's x minus 1. You can see the graph. That's exactly what we drew there. Okay, can you see it? At minus 2 and then passes through 1, touches at 3, and it goes on. This is perfectly continuous, but there are sharp edges at minus 2 and 1, minus 2 and at 1. Therefore, the function was not differentiable. So, you can use GeoGebra to verify, and I have also drew the graph for you manually without using the tool. Okay, so let's go to the next question. Now, I have to come back because I use the page. Very important question. Find the value of a and b so that this function is differentiable. He has not said anything, he has said the function is differentiable. So what is my statement? Since the function is differentiable, where at x is equal to 1 implies what? The function is continuous at x is equal to 1, because differentiability implies continuity. Differentiability implies continuity. Okay, now, so let's make use of the fact that it is continuous. So now what I will do, since the function is continuous, where at x is equal to 1, my left hand limit, what is my left hand limit? Limit x approaches to 1 minus f of x, my left hand limit will be equal to the right hand limit. Correct? So this is less than 1, this is greater than 1. So if it is less than 1, what is my function? If it is less than 1, my function is x square plus 3x plus a. Okay. If it's right hand limit, limit x approaches to 1 plus, if it's greater than 1, it is bx plus 2. LHL equal to RHL. Now direct substitution, you get 4 plus a, I'm putting x as 1, okay, equal to b plus 2. Therefore, I get a equal to b minus 2. Very important relation, I need this. Okay, let me call it as 1. Any question? LHL is equal to RHL. Now, he has already said that the function is differentiable. So, let's use the left hand derivative. So, let me just complete this. Left hand derivative. So, left hand derivative at 1. What is that? Limit x approaches to 1 minus f of x minus f of 1 divided by x minus 1. Okay. Now, since it is 1 minus, what is my function? Limit x approaches to 1 minus, my function f of x is 1 minus, it is x square plus 3x plus a. And what is my f of 1? In place of x, you put 1, so you get 4 plus a divided by x minus 1. Correct? So now what happens to this? This is limit x approaches to 1 minus x square plus 3x minus 4 by x minus 1. A and a cancels. I mean, if you know, numerator is a quadratic which can be easily factorizable as x minus 1 into x plus 4. Correct? Divided by x minus 1. So they get cancelled. When I apply the limit, you get 5. So my left hand derivative at 1 is 5. So let it be there. Now let's go to the right hand derivative. So right hand derivative at 1. What is the formula? That is limit x approaches to 1 plus f of x minus f of 1 divided by x minus 1. Correct? So this will be limit x approaches to 1 plus means my function is bx plus 2. So bx plus 2 minus, what is f of 1? If you substitute here, it will be 4 plus a divided by x minus 1. Divided by x minus 1. Correct? So now what happens here? This is actually limit x approaches to 1 plus bx plus 2 minus, you see 4 plus a, can you see 4 plus a? 4 plus a is nothing but b plus 2. So this will be limit x approaches to 1 plus bx minus b by x minus 1, because 2 and 2 gets cancelled. So this is nothing but limit x approaches to 1 plus b into x minus 1 by x minus 1. They get cancelled. So my right hand derivative is b. So now what statement do you make? Since the function is differentiable at x is equal to 1, left hand derivative equal to right hand derivative. What is my left hand derivative? Left hand derivative is 5. What is my right hand derivative? Right hand derivative is b. I got the value of b. Once you got the value of b, substitute in 1, you get a is 3. Very easy. Very, very, very important type of question. Very, very important. Okay. So let's go to the next question. Show that the function f of x defined as, it's a piecewise function, is continuous but not differentiable at 2. He is only talking about 2. Okay. So let's talk about x is equal to 2. So what is left hand limit? Limit x approaches to 2 minus. 2 minus means it's less than 2. Less than 2 means I have to use the second function. What is that? 2x square minus x. So when I apply the limit, it becomes 8 minus 2, which is 6. Correct? 8 minus 2, which is 6. Now what is the right hand limit? Right hand limit will be limit x approaches to minus 2 plus 2 plus means greater than 2. Greater than 2 means I have to use the third function. So when you apply the limit, it becomes 10 minus 4, which is 6. So clearly LHL equal to RHL. This implies limit exists. X approaches to 2, f of x equal to 6. Limit exists. What is f of 2? F of 2, you have to substitute x is equal to 2 in this. X is equal to 2. What do you get? 2 into 2 square minus 2, which is also 6. So clearly, limit x approaches to 2, f of x equal to f of 2. Therefore, what do you say? Therefore, I can say the function is continuous at x is equal to 2. So I have verified my first statement, that it is continuous. Now, is it differentiable? I have to go for left hand derivative. Left hand derivative at 2. What is that? Limit x approaches to 2 minus f of x minus f of 2 divided by x minus 2. Let us estimate the answer. So what is differentiation of 2x square? It is 4x. And differentiation of x is 1. Okay. So put x is 2. You get 8 minus 1. So the answer should be 7. So I should get my left hand derivative as 7. We'll see whether we get 7. So this is limit x approaches to 2 minus What is f of x? My f of x, since it is less than 2, it is 2x square minus x. And what is f of 2? When you put x is 2, I am getting it as 6 divided by x minus 2. So this is limit x approaches to 2 minus, this is x minus 2 into 2x plus 3. Quadratic equation. They get cancelled. Now put x is 2, what do you get? 4 plus 3, which is 7. See, I got that. 4 plus 3 is 7. This is shortcut, this is a procedure. Always we should know the procedure properly. So what is right hand limit? Right hand limit of 1, of 2, I'm sorry. Let us see. When you differentiate 5x minus 4, you get 5. So definitely your right hand limit should be 5. Okay, let's see whether we get it. So limit x approaches to 2 plus f of x minus f of 2 divided by x minus 2. So this is limit x approaches to 2 plus what is my f of x? It's 5x minus 4. And what is f of 2? F of 2 is 6 divided by x minus 2. So this is limit x approaches to 2 plus 5x minus 10 by x minus 2, which is like limit x approaches to 2 plus 5 is common, you get x minus 2 by x minus 2. They get cancelled. My right hand derivative is 5. Clearly you can see left hand derivative not equal to right hand derivative. This implies the function is not differentiable where? At x is equal to 2. That's what I have to prove. Clear? Very simple. Let's go to this question. Actually here there's a mistake. It should be e power x minus 1. Okay, e power 2x minus 1. Okay. It should be e power 2x minus 1. I just have a few more questions to do in continuity. I thought I'll complete that. Show that the function is continuous at x is equal to 0. So first I'll do left hand limit. What is my left hand limit? Limit x approaches to 0 minus. 0 minus means it's less than 0. Less than 0 means what is the function? It is sine 3x by tan 2x. Okay. Now what I do? This is limit x approaches to 0 minus sine 3x. Here what I do? I multiply and divide by 3. Okay. And again what I do? Limit x approaches to 0 tan 2x, right? I divide by 2x and I multiply by 2x. Now x goes to 0, 3x also goes to 0 and 2x also go to 0. So this will become 1 by the formula. This also becomes 1 by the formula. X and x get cancelled. So I get my left hand limit as 3 by 2. Correct? Now what is my right hand limit? My right hand limit is limit x approaches to 0 plus, it is log of 1 plus 3x divided by e power 2x minus 1. All class 11th portion, okay? So this is limit x approaches to 0 plus, here I am using the formula once again, 3x, divide by 3x, multiply by 3x, and limit x approaches to 0 plus e power 2x minus 1 by 2x into 2x. I am using this formula, I don't know whether you remember it. Limit x approaches to 0, log of 1 plus x by x is 1, and limit x approaches to 0, e power x minus 1 by x is also 1. So it is x, x and x. Whereas here it is 3x and 3x. So I have to put 3x goes to 0. Now here it is x, x and x, but here it is 2x. So I made 2x here. So 2x will go to 0. So obviously this becomes 1 This also becomes 1. X gets cancelled. I get 3 by 2. So what do you know now? Left hand limit equal to right hand limit. That means limit x approaches to 0, f of x is 3 by 2. Limit exists. Now what is f of 0? F of 0 is also given as 3 by 2. Can you see it? Therefore, what do you say about both? Limit x approaches to 0, f of x equal to f of 0. So it satisfies the condition. Therefore, what do you say? The function is continuous at x is equal to 0. Very simple, very beautiful sum. Let's go to the next question. Find the value of a for which the function given here is continuous. Okay, it's given that the function is continuous. So first I'll take the left hand limit. So what is my left hand limit? Limit x approaches to 0 minus. 0 minus means less than 0. Less than 0 means what? Sine of pi by 2 into x plus 1. All are in the angle. Okay. So now direct substitution. Wherever x is there, put 0. So I get a sine pi by 2. Sine pi by 2 is 1. So my left hand limit is a. Now what is my right hand limit? This is a class 11th problem. This is limit x approaches to 0 plus tan x minus sin x by x cube. Tan x minus sin x by x cube. So this is limit x approaches to 0 plus sin x by cos x minus sin x by x cube. Okay, and this is limit x approaches to 0 plus, I take LCM, so I get sin x minus sin x cos x by x cube cos x, x cube cos x, yes. Now what is common in the numerator? Clearly in the numerator, sin x is common. So what do you get? I get 1 minus cos x by x square, x cube into cos x. So what do you do here? I multiply and divide by 1 plus cos x. I multiply and divide by 1 plus cos x. So now what is 1 minus cos x into 1 plus cos x? It will be sin square x, correct? So already you have a sin x here. Sin into sin square will be what? Limit x approaches to 0 plus, it will be sin cube x divided by x cube. I group the sin x into sin square x will be sin cube x by x cube. What are the remaining things? Limit x approaches to 0 plus 1 by cos x into 1 plus cos x. Correct? And obviously this is 1. Cos 0 is 1, so I get the right hand limit is 2. Now since the function is continuous at x is equal to 0, LHL is equal to RHL. So what is LHL? My LHL is A, RHL is half. So I got the value of A. Okay. And there are a few questions which I thought I will do later because it's getting late. Okay. So 3 more questions which we can cover we'll do it in the next class. Okay. Kindly subscribe to my channel and also click the bell icon to get notifications. Thank you for your support. I hope these videos are useful to you. Okay. See you again in the next class. Have a lovely day. Bye bye.